The Mach-1 mechanical testing system can be configured to map the mechanical properties of samples with uneven surface using its automated normal indentation function and by fitting the results to Hayes' elastic model. This model describes the spherical indentation of an infinitely wide elastic layer bonded to a rigid half space, for example, articular cartilage over rigid bone. The data from the indentation of a 3D sample made of a single elastic material can also be fitted to the model if it is tested while being firmly attached to a solid platform. The effective sample thickness, which is calculated using the needle penetration technique, can be used in this case. From the previous folder path, select the corresponding normal indentation curve. Since I decided to analyze the 6th position ID for the sample thickness, I will do the same for acquiring the elastic parameters. Once again, verify that the position x and position y of this curve matches the scan x and scan y coordinates of the 6th position ID in the positions text file. You should also verify that the surface angle is less than 60 degrees. If not, the curve should not be further analyzed. Next, you should plot normal force versus normal position. From the Analysis drop-down menu, select Elastic Model and Indentation. Enter the model parameters specified in the associated protocol, that is, the spherical indenter radius, sample thickness, and Poisson's ratio. In this example, the femoral cartilage of a rat was tested using a spherical indenter with a radius of 0.5 millimeters. As obtained earlier, the sample thickness for this position ID was calculated to be 0.079 millimeters or 79 microns. The Poisson's ratio will be kept at 0.5 since cartilage exhibits incompressible behavior when loaded instantaneously and we require instantaneous properties. You can choose to curve fit up to the peak amplitude, but for now I will curve fit the results up to a position of 0.045 millimeters. You should now see a blue curve corresponding to the elastic model superimposed on the experimental curve with the calculated values displayed in the results field. Now you must open the previous results map file generated in Excel. As done earlier for the sample thickness, copy and paste the header columns for X number of characterizations. In this case, I would like to obtain the Young's modulus in megapascals and the elastic fit mean squared error or MSE. As done before, change the characterization header name in the format variable name followed by the units in parentheses with no spaces. It is not necessary to change the results heading this time as we have already copied it. Now simply copy and paste the Young's modulus and the MSE in the correct row of the position ID that is being analyzed, in this case the 6th position ID. As mentioned earlier, it is much faster to use Biomomentum semi-automated software for both the thickness and normal indentation analyses, which will be introduced later in this video series.